All righty, folks. Good to see you all. Good to see you. So we're going to go ahead and move on just a little bit more. We're going to have one more day dealing with our triangle trig before we move on into circles the remainder of the term. So just a little review over our laws of trigs, and we're going to look at one specific type of application. So first one, times when to use law of sines would be any time you're given two angles. So that'd be an angle side or an angle. Oh, looks like we did it twice there, didn't we? That should be angle side angle right there. We can fix that. So anytime we're given two angles, or we're given the SSA, ASS type of idea. So let's take a look at what those kind of triangles might look like here. So let's draw some triangles here. Ooh, ooh. So an angle side angle, that would be when I'm give you two angles. And then I give you a side in between. The reason why this is a law of sines is we could use these two angles to find the third angle. So we have an angle and a side opposite each other, and we can then find the rest of the sides. Or if I give you two angles and I give you either side, that's opposite it. And then we have the other one where I give you a side, a second side, and then an angle that's opposite one of those two sides. And you can kind of see, well, we already see the side there, but we can see where this is an angle side angle. We can see how this is an angle side, and then an angle side and a side. And we said this angle side or side angle, that's the one that doesn't necessarily make us happy. This is the one where we could possibly get the ambiguous case. The rest of them aren't guaranteed. And again, just because it meets our conditions of an ambiguous case doesn't mean that it is the ambiguous case. It just means it's possible. So we can have two sides. And one angle opposite a given side. The one given angle is less than 90 degrees. And the first angle we find, which is the second angle, is also less than 90 degrees. So this is what we said again, this is our perfect storm type of problem here. If this happens, then that means possible ambiguous case time. In the ambiguous case we looked at in class, it wasn't horrible, it wasn't bad, it's just a lot of work. So as long as you're organized on it, you'll be just fine. And then last class, we looked at our two law of sine type issues. And law of sines can be when we get side, side, side. We also looked at how that would allow us to use Heron's formula to find the angle of the triangle, or area of the triangle. And then we also had, so I give you all three sides. And then we also saw how the side angle side also was the law of cosines. And our rule was, if we're doing law of sines, we stick with law of sines. If we're doing law of cosines, we stick with law of cosines. So 4 out of these 5 cases gave us one triangle, and then this angle side, that one sometimes gives us one triangle, but there's a possibility that one could give us 2 triangles. So based upon what type of triangle we're dealing with, given the information, that tells us whether it's a law of sines or a law of cosines problem. So what we're going to do today is we're going to go through a couple examples of these just as a review, and then we're going to look at another example, another type of application that comes into it. So first thing we want to do, draw a triangle, friends. Draw a triangle. All right, so I'm going to say here that B is 63 degrees. And we have that little b is 11. Got big angle C, little c. We're big angle A, and we have that little angle A, or the side length A is 12. All right, well, friends, I was given two sides. And I was given an angle opposite one of those sides. So already that's the first characteristic. Well, this is a law of sines problem because angle side side or side side angle. This also means the first characteristic of the ambiguous case. If you notice that angle that we're given, that angle B, that was 63 degrees. So that right there, friends, my given angle is less than 90 degrees. That's the second thing we had to meet in order to be the ambiguous case. This could end up being the ambiguous case. Kind of hope not, but if it is, no problem, we got this. So what we're going to do here, friends, is we're going to go through and determine what kind of triangle we're looking at here. So we have sine of A over 12 equals sine of B, which is 63 degrees, over 11. So we're going to go through and get A by itself. And we already went through, both on videos and in class, the whole cross multiplication part. So I'm going to kind of streamline it a little bit here. You guys are probably like, oh, yeah, streamline it, shorter video. Yeah. All right, and what we're hoping for is that this angle right here is greater than 90. If it's less than 90, well, that turns it into an ambiguous case, which isn't a big deal. This means we're doing twice the work. So 76.41124.156. So since that angle is less than 1, or less than 90, that tells me that I'm actually dealing with an ambiguous case problem. So now I'm going to go back here. This isn't just angle A. It turns out this is angle A of the first of my first triangle. So we have to go through here now, and we have to figure out all the different information. So what I'm going to do right now is I'm just going to store this. I'm going to store it, this angle A that I just found, and I'm going to come back to it. I always like to go do the second triangle first. You don't have to do that. Again, it's just my little thing. And again, you would not put this down that you're storing something. I'm just putting it down there so you guys can see that I'm storing using the store button on my graphing calculator, and I'm going to store it as letter D. And then I'm going to go ahead and go take a look at the other triangle. So what would A be on the other triangle? It looks something kind of like this, friends. Let me see if I can actually play with it a little bit more. All right. Picking the wrong colors there. There we go. So now my A is going to open up a little bit. So here's my C, and that's going to be C2 now. A2 will be here. B is still here. That didn't change. And let's see here, opposite A is still 12. That's still 11. And this is little c2. So to figure out what A2 is, if I know that A1 is 76, A2 is going to be 180 minus that. Which would be 103.588 7584. All right, so we found that angle. I can go ahead and throw that in here. So 103.5888. Oh, probably should throw this one in here because we did find it. 76.4112. All right, so, and again, we're going to store this. So I'm going to store it as, since this is letter A, I'm going to store it as A. And then we'll keep going. So now if A2 is that, then we need to go find, looks like angle C2. So 180 minus 63 minus A2. And when we did that, friends, I found it to be 13.4112 4156. All right, so that would be C2. That's the measure of angle C2, 4112 degrees. And now we can find little c2. So sine of big C2. And by the way, friends, I did store that number as well. I stored that as C. And when we cross multiply, little c2 then is going to be 11 times sine of big C2, all divided by sine of 63 degrees. So C2 then, whoop, is about 2.86 342 0513. And I'm not going to use that one, so I'm not going to bother storing it. And we can find our area, our second area. So we said these ambiguous case problems, they weren't terribly bad, but what we did say is they do require quite a bit of work, right? Quite a bit of work. So we have 11 times 12. And again, I could use any angle as long as I use the two sides opposite it. So I'm going to use this angle since I know the two sides that are opposite it. I still have that stored on my calculator. And that was 15. 0.3080. All right, so finished off triangle 2. Now we go back to triangle 1. And like some of you guys asked, you said, can we do triangle 1 before we go to triangle 2? Yeah, it doesn't matter. It's whatever makes the most sense to you. I usually do it this way just so I don't forget triangle 2. I've seen too many people on their tests. They'll do the first triangle, and even though they said they were going to do the second triangle, they forget about it and they don't go back to it. So as long as you remember, I don't care what order you do it in. All right, so that C1 then, let's go 40.05887. 58875849. So that's this angle right here. So we'll write that in there, 40.5888. I always find it interesting that the decimals on A2 were the decimals on C1, and the decimals that we'll find on C2 were the decimals on A1. I always find that a little interesting, a little fascinating. All right, now we got to go find little c1 now. So sine of big C1 over C1 equals sine of 63 over 11. And by the way, I did store that. I guess I probably should put it down. And again, it doesn't matter what letter you store it as. So I stored it as F. And that means that little c1 here is 11 times big sine of c1 all over sine 63. So little c1 then is 8.0323 5148. So we can go ahead and throw that in here as well. There we go. 8.0324. Last thing we got to do is just find the area for it. So area of the first. And I would use on that one, I would use, again, still 11 and 12. I'm going to use C1 this time. Again, we could use any angle and just use the two sides that are adjacent to it. But notice I did a law of sines problem here. So since I was doing a law of sines, I stuck with law of sines all the way through. And we end up with 42.94126. Nine, 4, 1, 3. All righty. Why don't you guys go ahead and pause the video if you wanted to go ahead on to the second one, and then we can take a look at it here in a second. If you didn't get it, if you don't have the notes there, that's what the second one looks like. Go and pause it. All right, let's see what you guys came up with. So here's my angle B. I got 63 degrees. I got C, which is 11. I got a, little a, which is 12. And notice, if you're looking at it here, it looks like this. I have a side, I have an angle, and I have a side. So side, angle, side. This is a law of cosine problem, which means there's only one triangle. So since it's a law of cosines and only one triangle, I can go right over here, and I know that these don't exist anymore. There is no second triangle, so they are gone. All righty, well, let's go see if we can't figure this out. First thing I want to figure out here is what is the side opposite angle B? So that'll be little b. So b squared, we're going to use our law of cosines here. B squared is a squared plus b squared, or 12 squared, minus 2 times 11 times 12 times cosine of big B. So we plug this into our calculator here, and we find out that B is approximately 12.04767 646. I can plug that in here. 0.477. And again, I'm going to store that. And again, we wouldn't write this down on our paper. I'm just writing it so you guys can see exactly what I'm storing on my calculator. I stored that as B. And now I can go through and figure out any angle I want. So I can figure out either angle A or angle C. I'm going to use angle A, which means the side that's going to be by itself will be 12. So 12 squared equals 11 squared plus B squared minus 2 times 11 times B times cosine of A. So when A is by itself, we get 12 squared minus 11 squared minus B squared all over negative 2 times 11 times B. Which would be about 62.5583391. Five, 5, 8, 3. And friends, again, I stored that. Technically, I didn't actually store it. I used the second answer button on my calculator, but just for purposes to keep things straight, we'll go and store it. And that means then that C is 180 minus 63 minus A. So 54.4416609. And now we got to find the area, friends. So the area for the whole thing is 1/2 AB sine C. So 1/2 11 times 12 times sine of 63 degrees. So find the angle you want to use. In this case, I used angle 63, and then it's going to be the two sides that are right next to it. The nice part about this is they gave me everything that I wanted to use. So the area is about 58.80 64306. All right. Well, let's keep going. We're going to look at one type of navigation. Now, friends, this is not to be confused with navigation from airplanes and bearing with that. This is sea bearing, not air bearing. Okay. We'll deal with airplanes when we get into vectors a lot longer. All right, what we're looking at is a very special type of bearing. And this is more sea bearing. Now, when we're looking at these, we're looking at direction. And so we're going to be talking about compasses. So let's start off, let's look at what compass locations look like here. So first up, whenever we're dealing with compasses, we're either going to start from our north or from our south. So I can be going from north over to west, or I can be going from north over to east. I can be going from south over to west, or I can be going from south over to east. So if I'm going from north, then I'm going to give you some angle towards the west. We would say that this is north, whatever that degree is, towards the west. If I'm going towards the east, it's a different angle. We'd say that this is north, whatever that angle is, towards the east. Notice the bearing, these angles are called the sea bearing angle. They're always starting from either north or from south. So south towards the west, south degrees west, or I'm going towards the east. So south, some angle measure towards the east. So when we are looking at this, every time we change directions, you always kind of want to make yourself a little compass, just so you can kind of start off. So let's see what happens here. The ship leaves a port heading due west. All right, so I'm going to go ahead and make my port here. And I'm going to go ahead and write this as port. And I am going due west. So that means I'm going to be starting off here, and I am going due west. So I'm going to be starting at this port, this point of origin here, and I am going due west. I mean straight west. And I went 16 knots, that's nautical miles, 16 knots at 3 p.m. So in other words, 16 knots or nautical miles at 3 p.m. And I changed at 6 p.m. So from 3 p.m. to 6 p.m., I went 3 hours at 16 knots. So 3 times 16 should be 48. And then at that point in time, it says I changed my direction. So let's go ahead and change our direction here. and I change to north. So I'm going to start at north. North, and I went 37 degrees to the west. So I'm going to come back 37 degrees to the west. So that means I went from north and I went 37 degrees that way. And at that point in time, friends, I traveled 14 knots. So I stopped at 8 p.m. So from 6 p.m. to 8 p.m., I went 2 hours at 14 knots. So that meant I went 28 nautical miles that way. What I'm being asked here is, what is my true distance that I went? In other words, if I would have started from port and went out here, what was that true distance that I traveled? That's what part A is asking. True bearing, it means if I would have just started here and taken and figured out what this measure is down to here, what would have been that true bearing from port? I know I went from north, but how far over would I have gone over if I wanted to just go straight to where I ended up? So this looks like, if we put it all together here, I know two sides, 48 and 28, and I know this angle in between. So this is a right angle plus 37. That is 127 degrees. So friends, it turns out that this is a law of cosines problem. So d squared equals 28 squared plus 48 squared minus 2 times 28 times 48 times cosine of 127. Friends, that would be about 68.5979 5028. And yeah, I'm pretty sure you know what I'm going to say right now. I stored it. And I'm going to store that as letter D. All right. So I have my distance in. I went 68.57 or 5979. So 5980. Nautical miles or knots. So in order to figure out my true bearing, I need this angle right here. But in order to find that, I need to first figure out what this is right there. Because this angle right here is going to be 90 minus theta. So we're going to go and figure out what theta is. And again, we're using law of cosines. We start with law of cosines. We stick with law of cosines. So the side that's opposite the theta, that would be 28. So we're going to put 28 by itself. So 28 squared equals 48 squared minus d squared. Plus, sorry about that. Minus, there you go, 2 times 48 times d times cosine of theta. So we got to get theta by itself. So that's going to be 28 squared minus 48 squared minus d squared all over -2 times 48 times d. And that ends up being 19.0251657. That's not what I wanted. Remember, I wanted 90 minus theta. So that's what that theta right there, that's the angle in the triangle. That's not necessarily the angle that I'm actually looking for. So this is my bearing angle right here. And again, it's not always 90 minus theta. It's really important, guys, on these that you draw pictures so you know what you eventually have to do once you solve your triangle, that you know what to get to in order to get your bearing angle. Now notice, if this angle was more than 90 or if this angle right here was, this theta was more than 90, that would have put me, instead of coming from north, I would have came from south. So it's very important that I know how this whole thing matches up. So just be aware of that. There's my true bearing right there. Well, you can kind of see the problem down below. So why don't you go and pause the video and try the second problem, and then we'll call it a day. All right, let's see how y'all did on this one. So first up, I'm starting out, and I am going south 19 degrees to the east. So I'm going south, and I'm going 19 degrees to the east. So that's 19 is right here. And when I did that, friends, I traveled. I started at noon. I went 18 knots, and I started at noon, and I went till 4 p.m. So I went there from 4 times 18, which was 72. That'll be the side of the triangle. And then from there, I'm changing course. From there, I changed to north, 72 degrees to the east. And for that, I started at 4 p.m. and I went till 6:30 p.m. So that's 2.5 hours at 14 knots. 2.5 times 14. Which would be 35. So they wanted me to figure out how far I am from port. Here's my port. And what is my true bearing? So now notice on this one, to find my true bearing here, eventually, I got to go past the 19 degrees, and I got to figure out whatever that eventually is, and I'll end up adding those together. So my true bearing this time, I'm going to add together to what it is. So I got to eventually figure that out. I'm going to need to know my distance But my distance is opposite this 72 degrees. Well, now this is a little bit different. How do we go about figuring out what that angle is? So let's think here. It goes up. What kind of angles form the letter Z back in geometry? Those are alternate interior angles. So that means if this was 19, that means this one right here also would be 19. So this is actually really close to being a right triangle. Not quite a right triangle, really close though. So that means I'm dealing with these two angles together here, which makes it 91 degrees. Really close to being a right triangle. So close. All right, let's go figure out what D is. So D squared equals 72 squared plus 35 squared minus 2 times 72 times 35 cosine of 91. So we have 80.626 4543. And of course, I'm sure you've guessed it, I am going to store that. I'll store that as D on my calculator. And again, I wouldn't put the store D down. Nobody needs to know that. That's just for me. So 80.6265 nautical miles. So we start with law of cosines. We're sticking with law of cosines, and I've got to go and figure out what that angle theta would be right there. So the side opposite theta is 35, so 35 is going to go by itself on one side of the equation. So 35 squared equals D squared, which I just found, plus 72 squared minus 2 times 72 times D times cosine of theta. So we get theta by itself. And we have 35 squared minus D squared minus 72 squared all over negative 2 times 72 times D. So theta is about 25.72352095. And again, if you look at the bearing down here, the bearing started from south and went all the way over. So it had to cross the 19 degrees to the theta. So my bearing angle, this time I'm going to actually add my two angles together. And again, draw a picture so you can reason out what's going on with your bearing. So in this case, I have my theta. I'm going to add 19 to it. And I end up with 44.7235 2095. So in other words, I'm starting from south and I'm going to the east. So south 44.7235 degrees to the east. All righty, friends. Well, that kind of takes care of that. Starting next class, we will start looking at angles on circles. All righty, take care.